Happy Tuesday afternoon. We're continuing with applications of the derivative. Now our focus for the next few classes will be on the shape of a graph, the behavior of a function. So this first little bit's going to be essentially a more in-depth discussion of pre-calc. So in pre-calc, you should have studied increasing and decreasing, right? And extrema, both absolute and local extrema. However, we could only determine those from a graph before. Well, using calculus, we can find it without a graph. That's what we're going to look at. Absolute extrema, also called global extrema. You have a function defined over an interval I, and C is some point in that interval. F has an absolute maximum on I at C if f of C is greater than or equal to f of x for every x in your interval I. And then a similar idea for absolute minimum. Right? And collectively, they're known as extrema. Singular is extremum. I'm going to go through this pretty quickly because this should be a review of pre-calc, the definition. This one, however, should be known. Right, so absolute maximum is just the largest value on an interval, absolute minimum is the smallest value on an interval. And collectively, they are extrema. Have you heard of the extreme value theorem? Does that sound familiar? So this is new. You know it's important because it's got its own meaning. If f is a continuous function over the closed bounded interval a to b, then there is a point in that interval at which f has an absolute maximum, and there's a point in the interval at which f has an absolute minimum. So what this is saying is every continuous function over a closed interval takes on both a maximum and a minimum. The terms absolute and global used interchangeably. I stick with absolute. I don't remember what your text uses. I think your text also uses absolute instead of global, which is weird because then they use local instead of relative. Relative extrema or local extrema, again, interchangeable. Function f has a relative max at C if there exists an open interval containing C, such that I is contained in the domain of F, and f of C is greater than or equal to f of x for all x in I. Okay, so it's a relative max if you can find an interval where it is the maximum value. And likewise for relative min. Right, there's a relative min at C if there exists some open interval I containing C, such that I is contained in the domain of F, and f of C is less than or equal to f of x for all x in I. So you can create an interval where C is the smallest value. And collectively they are called relative extrema. Oh, I need to change that. Let's see. But now the question boils down to how can we find them? Well, today we're just going to look at global, the absolutes. Algebraically, right, we're also looking at graph for I for a relative. And then next time we'll dive more in depth with the relative. We need the idea of a critical number. Let C be an interior point in the domain of F. That means that C is in the domain. C is a critical number of F if f prime of C is 0 or f prime of C is undefined. So critical numbers are numbers that make the derivative equal to 0 or undefined. Then the point C, f of C, would be a critical point of F. And I will be using those interchangeably. I'll typically refer to them as critical points when I want the numbers. Another important theorem has a name. Fermat's theorem. Silent T. If f has a local extremum at C and f is differentiable at C, then f prime of C equals 0. As a corollary to this, if f has local extremum at C, then either f prime of C is 0 or f prime of C does not exist. In other words, your extrema occur at critical points. This does not say that every critical point results in an extremum. It's just that critical points will always be, I'm sorry, an extremum will always be a critical point. F be a continuous function over a closed bounded interval I. Absolute extrema of f over that interval must occur either at the endpoints of the interval or at the critical points of f in your interval.
How would we check an interval to see if the extrema aren't one of the endpoints? We just basically solve it?
We'll go over that. I have a prompt on that. But yeah, what you do is you just find the critical points first, then test the two endpoints and the critical points. Largest value is your maximum, smallest value is your minimum.
All right.
Rolle's theorem. I'm not going to spend too much time on this. I only introduced this here because I'm going to be using it in the lecture videos to prove stuff. I think specifically to prove the mean value theorem, which is more important. Let f be continuous over the closed interval a to b and differentiable over the open interval ab. Then there exists at least one c in that open interval, such that f prime of c is f of b minus f of a over b minus a. So the value on the left, f prime of c, what is that? So what did the derivative represent?
Well, assuming that's 0 or undefined, that's a critical point right there.
Well, I'm not saying that it is a critical point. Just in general, what is a derivative? What does it represent?
The rate of change at one specific spot on the graph.
Instantaneous rate of change. What about the value on the right? What is that?
Yeah, that's just a slope formula.
Right? Slope. Think physical.
Change in y over change in x.
Which is also known as what?
I already said that's the slope formula.
Sure, it has another meaning. It's slope of the secant line, or if you're thinking physical. Average rate of change. Right, delta y over delta x is an average rate of change over the interval.
Okay.
So notice what the mean value theorem is actually saying. It says that for any continuous function over an interval, there is a point that is guaranteed where the average or the instantaneous rate of change equals the average rate of change. And so if I put that into physical terms, you go on a road trip and you average 60 miles per hour, there's going to be some point in that trip where you were going 60 miles per hour. There may be multiple points, but there's guaranteed to be at least one point in time where you're going exactly 60 miles per hour. That's what the mean value theorem is saying. It's very important. And Rolle's theorem is used to prove this. And this will be used to prove some things later. So we're going to start with where we're given the graph and we're asked to identify each point as an absolute max, absolute min, relative max, relative min, or none.
Do we have intervals?
The interval is already given.
Okay, so over that entire thing.
That is the interval. But whenever there's a point on the end, whether it's open or closed, that means that's the end of the interval, right? So it's not going to continue on forever. So look at point A. What is point A?
Well, that's undefined.
So of those 5 options, which one is it? Yeah, it's none of them. For that very reason. The point doesn't even exist. What about B?
That's an absolute maximum.
So your wording.
Over that interval.
It's not an absolute max. It is the absolute max. Function can only have one absolute maximum value. Right, that's the definition of absolute. That's what it means to be absolute. So that's just syntax there. What about C? Actually, I'm not done with that yet. Isn't that also a relative max? Absolute extrema are relative. Right, so that's actually both an absolute and a relative, but the idea was just to name one of them. So it's clearly the absolute maximum, so I'll stick with that. But keep in mind, you could also say it's a relative. What about C? That is a relative min, right? By the way, if you look at C, where B, the derivative is 0, right? What about C? That derivative is undefined. Right. Remember, when you meet at a cusp like that, your derivative is undefined. It's a vertical tangent line. What about the point D?
That's going to be both.
Why?
It's undefined.
It's undefined. What about E?
That's also not zero.
Why?
It's in relatively maximum, relatively minimum. It's just kind of there.
You can't find an interval where it's the largest or smallest value, right? No matter how small you make the interval, you're always going to have points larger than it and points smaller than it.
I assume we can't do an interval just E.
That's not an interval.
Okay, so that's just
That's a point. What about F?
Relative minimum.
It's relative min. Would it be the absolute min? Nope.
No, there's some spots near A that are
Does this function have an absolute min?
not one labeled. I mean, we could just
It's not labeled because there's none,
yeah, we could just keep getting closer and closer to A. But, yeah.
right? It keeps getting closer and closer and closer to f of a without ever touching f of a, so it can't have an absolute min.
If we make it the absolute minimum limit.
No, because that point, the limit would be a, would be whatever this value here is approaching -2. That's the limit, but that point doesn't exist. F never takes on the value -2.
All right.
So by definition, then it can't be a min.
All right.
And what about G?
So relative maximum.
Really easy, right? It'd be really nice if your second exam was just a bunch of those types of questions. Right?
I feel like this is the last graph we're going to see.
It's not. But I can all but certainly guarantee that you won't see graphs on the actual exam itself. See, another graph. So same thing. A,
Absolute minimum.
what about B,
None of the above.
C,
Absolute maximum.
D,
None of the above.
E,
Relative minimum.
Okay, so now we have a fairly good understanding of what an absolute max, absolute min, relative max, relative min are. Without graphing, we will now find all of the absolute extrema. Like I said, the relative extrema we will look at next time. So now we're just focused on the absolute. So remember Fermat's theorem. Extrema occur only at critical points. If we're looking at a continuous function on a closed interval, then your absolute extrema will occur at either the endpoints or the critical points. So that's the first thing we have to do is find the critical numbers. What's a critical number?
Place where the derivative is either 0 or undefined.
Which means the first thing we need is the derivative. What is the derivative? Is there anywhere that would be undefined? No, it's a polynomial, defined everywhere. Only critical numbers are going to be where that is equal to 0. So set it equal to 0 and solve. This is relatively simple to solve, so I'm not going to use a calculator. It's quadratic. More importantly, I can make this an easier quadratic. Multiply everything through by 1/3. Can that be factored? Was it factor 2? All right, and then the 0 property will ultimately give us this. X is -2, or X is 5. Those are the critical numbers. But what's the interval we're looking at? So the only critical number we have to worry about is 5. Actually, I'm going to make it this way instead. You don't have to change it. I'm doing it this way because I don't have enough room to do it the other way. Start with the smallest x value I see, which is the endpoint 0. What is f of 0?
3.
Next number is 5. What's f of 5? Negative 269 over 2. And then finally, the right endpoint 6, f of 6.
-123.
So look at those 3 values. Which one's the largest? That's your absolute max. Of those values, which one is the smallest?
-269 over 2.
That's your absolute minimum. There you go. So 3 sine of x on pi over 4 to 2 pi over 3. What's the derivative? Is there anywhere that is undefined?
Cosine undefined at I think half pi and no, then 0 pi. What is this undefined?
You're thinking of secant and cosecant.
Oh. Okay.
Domain of cosine is all real numbers. It's defined everywhere. Right? Secant wouldn't be defined at odd multiples of pi over 2 because then cosine would be 0. And secant's 1 over cosine. So set it equal to 0 and solve. That would mean cosine of x is 0. I just said it, cosine is 0. At every odd multiple of pi over 2. So it has an infinite number of zeros. But remember, we're looking at a restricted interval. So look at all of those infinite number of zeros. Which of those points lie within our interval?
Just pi over 2.
Pi over 2. And so in this interval, we have a single critical number, and that's pi over 2. Left endpoint. What is sine of pi over 4?
Square root of 2.
Yeah, I felt like you're not confident. Dude, that just makes me sad too.
27 and 7.
Oh dear. Now I just want to get something. Chuck that in here. Find something I don't need. Anyway, so it's too far away. I think your approximation is correct, but I don't like approximations.
You were right the first time. It is square root of 2 over 2.
Good. Should be more confident. Next up, pi over 2, the critical point. What is sine of pi over 2? One. Finally, 2 pi over 3. What is sine of 2 pi over 3?
Negative.
What is sine of pi over 3?
Square root of 3 over 2.
2 pi over 3 is quadrant 2. Is sine positive or negative in quadrant 2?
Well, that'd be positive.
So sine of 2 pi over 3 is root 3 over 2. Of those values, what's the largest? And you shouldn't need a calculator for this.
3.
3 is the largest. What is the smallest?
3 times the square root of 2 over 2.
Yeah. First, we need a derivative. How'd you go about finding this derivative?
Product rule.
You would do it. It's not how I would do it. I would use a calculator. Because I'm too lazy to do product rule. We're outside of derivatives now. I'm not testing if you can take a derivative anymore. Unless the problem on the exam specifically says you can't. Well, actually, I think the way I wrote the exam is you can only use it if the problem tells you you can.
Well, this problem doesn't say we can.
That's for the exam.
Okay.
Right, because the exam, I still have to test if you can take a derivative, right? Because the first exam only went out through quotient rule. Second exam starts to change rules, so there's still questions I have to. So, menu, calculus, with respect to x, x squared times square root 4 minus x squared. Enter, there it is. I don't like that form. Will it let me, if I do this, algebra, denominator is. Well, that's really annoying, isn't it? You don't have to simplify command. Let's just see what this gives me. I'm not hopeful. What's this convert expression? Oh, that's that. Fractions equals common denominator. I think that's just going to give me what the actual common denominator is. No, it doesn't. Yes. That's what I wanted.
Oh, is that our form?
That's the derivative I'm going to be using. And here's what you do. You hide the calc and you just write this. And say it's obvious.
That doesn't look like it was just on the website.
It is.
Okay.
8x minus 3x cubed all over the square root of 4 minus x squared. And so just say it's obvious and trust all your friends. Where is that undefined? Which means those are critical numbers. So that equal to 0 and solve. Does it mean that 8x minus 3x cubed would have to be 0? Factor out a negative x. Negative root 8/3, 0 and root 8/3. 5 critical points. -2, +2 are endpoints, so they don't really contribute anything. Because you're going to test those anyway. Now the question is, of those last 3, which are in the interval? All of them are. That's 5 points we have to test.
You still have to test -2 and 2, even though they're undefined.
The derivative is undefined at those points. The function itself isn't. Otherwise, they wouldn't be in the domain, so there wouldn't be critical points. Start with -2. What is f of -2?
0.
What about -8 or negative root 8/3?
I have an approximation.
I don't want approximation.
I don't have anything.
What is 12 minus 8? So 16 over 3 root 3? Or 16 root 3 over 9? What's f of 0?
0.
What is f of root 8 thirds?
Square root of 9.
16 root 3 over 9. Squaring makes the negative irrelevant. And the last point is 2. What is f of 2?
0.
This is going to be tough. Of those 5 values, what's the largest? That's your maximum value. How many times does it occur? One maximum that happens to occur at 2 points, which is allowed. What's the smallest value?
Zero.
How many times does it occur?
3 times.
So again, there's one absolute min. It just occurs at 3 points. In this case, every single point happened to be an absolute extrema. Now for the moment that a lot of you have been waiting for. L'Hopital's rule. One of the textbook I have actually spelled it wrong. It's spelled as Hospital. Yeah. I have no idea why they spell it that way. But L'Hopital. 2 forms of L'Hopital's rule. First is 0 over 0 form. If the limit as x approaches a of f of x is 0 and the limit as x approaches a of g of x is 0, then the limit as x approaches a of f of x over g of x is the limit as x approaches a of f prime of x over g prime of x, assuming that the limit on the right exists or is infinite. This result holds if we are considering one-sided limits or limits at infinity. So if you get indeterminate form of 0 over 0, you can use L'Hopital.
Will there ever be a situation where we have to use this, or is it just a good shortcut?
I don't think you ever have to use L'Hopital. It's just the algebra might be really, 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 really bad. So you're better off using it.
Okay. Because I remember we had a way to work around those indeterminate forms.
Yeah, this is really going to be useful for those times where the algebra is just terribly hideous. The other form is the infinity over infinity form, and it's the exact same thing, except you get a form of infinity over infinity instead. And that's it.
I feel like those can just be condensed into one rule.
It would be really messy to write it that way. It is one rule. We just write it with two different indeterminate forms. Those are the only two indeterminate forms you can use L'Hopital with. 0 over 0, infinity over infinity. If you get any other indeterminate form, L'Hopital does not apply. But you can manipulate it to get you one of these two forms. And then you would be able to use L'Hopital. If you plug in pi, what do you get? What's sine of pi? What's pi minus pi? Oh, good. We get 0 over 0. What is the derivative of sine? What is the derivative of x minus pi? What's cosine of pi? -1. Limit's -1. That's L'Hopital's rule. So you asked if you have to use L'Hopital's word, right? You don't have to do it.
Yeah, I'm gonna use it.
Fine. It's actually not that bad
Yeah, I'm gonna use
to
it.
not use L'Hopital's word. I'm gonna say no, we're not using L'Hopital's word.
Overlearning is positive, which is
Huh?
overlearning is
Nope.
Doing this on purpose to spite
Because I could also say on an exam, not allowed to use L'Hopital's word. And
corrupt bargaining.
it's a dictatorship. Get used to it. Double angle identity for cosine, which is now difference of squares. Cosine of pi over 4.
Square root of 2 over 2.
What is sine of pi over 4?
Same thing, square root of 2 over 2.
What's root 2 over 2 plus root 2 over 2? Which is exactly what you would get using L'Hopital's word.
Yeah, I thought root 2 over 2 plus root 2 over 2. Wouldn't that just be root 2?
Mhm.
That's not what you wrote.
Sure it is. The cosine plus sine was in the denominator.
Right.
Approach 0 from the right. This is 0 over 0. What is the derivative of the numerator?
Yeah.
What is the derivative of the denominator?
2x.
What happens as x approaches 0 from the right? Which is what? But we're approaching 0 from the right. So that means that 1 over 0 is going to be infinite. Question is it plus or minus?
Plus.
Plus. to infinity. Right, you get that because your values of x are larger than 0, which means 2 times x will always be positive. So it's increasing without bound. Plug in infinity. What do you get?
That's weird. I thought infinity was infinity.
Why is that weird?
It's just weird.
It's indeterminate. So use L'Hopital. Yes, I know every class coming up. Derivative of the numerator. Derivative of the denominator. Plug in infinity. What do you get?
That's weird. I got infinity over infinity.
Oh, infinity over infinity. We can use L'Hopital. Derivative of the numerator.
12x squared.
Derivative of the denominator.
3x.
Plug in infinity.
Oh, that's weird. It's got infinity over infinity.
Ah. Great, but that means L'Hopital. Derivative of the numerator.
24x.
Derivative of the denominator.
E to the x.
Plug in infinity.
Oh, this is so weird, guys.
So we can use L'Hopital again, right?
Yes.
Derivative of the numerator.
24.
Derivative of the denominator.
E to the x.
Plug in infinity.
Oh, that's very normal. I got 1 over infinity.
Should have gotten 1 over
I
infinity,
got 24 over infinity. Sorry, I jumped the gun there.
which is 0. The purpose of this problem is to show that you cannot use L'Hopital's rule more than 1 time. As a reminder, I will not be here on Thursday. Which means I won't see you again until Monday.
Thank you so much.
Enjoy the rest of your week, and you should get a message on Teams on Thursday as well.